And welcome, students. As we get into our first topic for Programming 3, we're going to discuss the ArrayList class. So let's just start off by talking about, first off, what is an ArrayList? Well, an ArrayList is a class within the standard Java libraries. So it's not something you have to go and import. You can kind of think of an ArrayList object, therefore, as an array that can grow, or shrink, rather, in length while your program is running. So it gives you some good flexibility in there. So remember we talked like partially filled arrays, we kind of have to do a little finagling. Well, ArrayLists, they have the ability to grow and shrink. Now in Java, you can read in the length of an array while the program is running, but once your program creates an array of that length, can't change the length of the array. Now, with a traditional array, it's fixed. So if you have an array, let's say of size 12, once you hit execute, that array will be fixed at size 12. There's no changing. You can't make it bigger, can't make it smaller. There's no way to modify it. You could copy the contents over to a bigger or smaller array, but that's not necessarily manipulating the original array. That's finding a new array. So let's just look at an example here. Suppose we want to write a program to record customer orders for a mail order house. And suppose you store all the orders for one customer in an array of objects of some class called item. You could ask the user how many items he or she will order, then store the number in a variable called number items and create the array with the following statement. Item equals new item number of items. That's one way you could do that in our traditional approach with arrays. But let's just say the customer enters the number of items and decides, hey, I need one more thing. It's like I was going to get 5 things, and I saw there's this great sale on this other thing I want to get. I want to get that thing too. Well, unfortunately, there's no way to increase the size of the array item. So if they start with 5, they're stuck with 5 until they complete the transaction or they start over. There are kind of some ways around this problem with arrays, but they're all rather complicated. I did mention copying one array over to another array. That's one strategy. But again, you're not really manipulating the original array then. Now, array lists can serve the same purpose as arrays, except that an array list can change the length while the program is running. So array lists have a little more power and flexibility built into them. So an array list could technically handle the customer's extra order without any problems. Now, the class ArrayList is implemented using an array as a private instance variable. When this hidden array is full, a newer, larger hidden array is created, and the data is transferred to this new array. So this is kind of doing what I kind of already mentioned. We can make an array of size 5. We're going to copy over to array of size 6, and off we go. Well, that's kind of what ArrayList is doing behind the scenes. So it's taking that original hidden array, copying it over to a new array of a larger size. However, we don't actually have to worry about the behind-the-scenes stuff that's going on here with the copying of that private array to the new array. We just need to use the ArrayList class. Java is going to handle all that behind-the-scenes stuff for us in terms of ArrayList. All we need to know, ultimately, is how to use the ArrayList class. And, well, let's actually get into how to do that. Now, think about this. If array lists are like arrays, but they have that nice added feature of being able to change length, then you might ask, well, why don't I just use an array list instead of just using an array? Because that's pretty handy. Well, every silver lining has kind of a cloud, and this is true of array lists as well. There are 3 main disadvantages with that of an array list. They're less efficient than arrays, right? Because the array list is like a class object, and rather than more like a primitive object structure, they have less efficiency when it comes to system processing. So if you're looking to develop a application that is all about speed and a priority on that for performance, you're going to want to stick with an array. If that's not as much of an issue for you, then an array list is perfectly viable. Array lists also don't have the square bracket notation that we're very much used to with arrays. And so using an array list is sometimes notation a little bit more awkward than that of using an ordinary array. We're very used to using just a square bracket for an array, and off we go. Now, the base type of an array list must either be a class type or some other reference type. It can't be a primitive type, such as int, double, char. So you cannot just say, hey, I'm going to make an array list of ints. Java's not going to like that because it has to be pretty much like a class type. So let's just say, for example, we do want an array list of integer values. Well, we have to simulate this structure of array list using integer values. Notice where integer is the wrapper class object whose objects simulate int values. So you'd have to use the integer class here to kind of sneak around this little weakness. Now, automatic boxing and unboxing make that third point less of a problem. So even though there's 3 disadvantages, we can kind of get around it by using the wrapper classes. Now, because array list of the base type, for example, array or integer, can in fact store those values of int, we can still kind of get into using those parameter types such as int, double, and char. All right, if we want to actually use the ArrayList class, these are used much in the same way as arrays, but there are some important differences. So first off, the definition of the class ArrayList is not provided automatically. The definition is in the package java.util, so you will have to import this. All right, so I might have said you don't need the library. We don't have to do anything special. They are in the Java libraries, but you do have to import it. All right, and any code that uses the class ArrayList must contain the following. Typically we put that header just like we do every other import statement: import java.util.ArrayList. Pretty simple. Now, ArrayList is created and named the same way as any objects of any class, except that you specify the base type with a kind of new notation. So, for example, ArrayList, and notice it's a normal bracket, like much more than we're seeing in HTML, string, and then list equals new ArrayList string of 20. All right, so we got some ideas of how these ArrayList works, but what about capacity? Well, this statement makes the list of the array, the name of the array list that stores objects of the class string, have an initial capacity of 20 items. So if we go back here to the construction of that string, you can see this string object for this array list has 20 objects. You're like, but wait, we can make it of any size because it can grow or shrink. That's correct. But you have to give it that initial size in order to create the object to begin with. Now, when we say an array list has that certain capacity, we mean that pretty much it's been allocated memory for that many items. So we say, hey, set aside 20 slots of memory for those string items. But if we need to have it hold more items, well, the system's automatically just going to allocate more memory. We don't have to go crazy about it. Now, be careful when you're choosing the initial capacity of ArrayList because you can often make your code much more efficient. But this capacity has no effect on how many items the ArrayList can hold. So if you say, hey, I think the person's going to start out with a size of 5, you can do that. You can say, I'm going to set to 5 every time, or I'm going to set to 10, or I'm going to make it 100. Go for it. But if let's say you make it 100, but people are only, let's say, entering on average, let's say 10 items, that's not necessarily a very efficient use of memory, so you may want to scale that back. So just to give a kind of a rehash of that, so if we choose our capacity to be large enough, then the system does not need to reallocate memory too often, and as a result, our program should run faster. On the other hand, if we make it too large, we're going to waste storage space. So you have to try and find that nice happy medium when you're creating your array list. However, pretty much no matter what capacity you ultimately choose, you can still kind of do anything you want with the array list. Now, let's take a moment to talk about type interference and base type. Java supports a slightly shorter but equivalent way to define the array list. In this format, the base type in the call to the constructor is not needed. For example, ArrayList string list equals new ArrayList 20. You'll notice that there is no string defined between these two brackets. Now, this feature is called type inference and is briefly discussed in an upcoming lesson. The type string in the previous ArrayList example is the base type of the ArrayList class. Now, ArrayList that is an object of the ArrayList stores objects of its base type. So you can do it this way. It is perfectly viable to do it. If you just wanted to make it a little shorter, the difference is that you do add some clarity for your own sake. So As we kind of mentioned, you can use any reference type as the base type of an ArrayList class. In particular, you can use any class or interface type. However, you cannot use a primitive type, just as we've already mentioned, such as int or double as the base type. This is an example, of course, of a type parameter. The ArrayList class is defined as having a type parameter for the type of the elements in the list. And we can create a concrete class by specifying in angular brackets a class type to be substituted for this type of parameter. So, for example, string. If we look at the following code, which you saw earlier, we substitute the type string in for the type parameter to create the class ArrayList string and an object of the class named list. So ArrayList string list equals new ArrayList string 20. Of course, remember, you can take out this one right here. Me personally, I would prefer to keep that in there simply because I know, even though I know it's a string type here, it's just a little bit easier to look at. Now, if I say I'm not going to do that, I'm just always going to do inference, that's perfectly fine as well. So you can do whichever way is more preferable to you. All right, real quickly, let's talk about set. An ArrayList object can be used pretty much like arrays, but they don't have the array square bracket notation, as you've already noticed. If you use like a index equals hi mom for an array of strings A, then the analogous statement for a suitable array list is named list is list.set index comma hi mom. So this is how we're going to have to do it with an array list, because remember, an array list is a class. So we have to use like a set method that we've used to do with other various classes that have done accessor and mutator methods. Now, if we wanted to, let's say, have string temp equals a of index for an array of strings A, then the equivalent statement for a suitable array list would be string temp equals list.getIndex. So a little bit of transition here of how to use an array list. Now, let's actually talk about creating and using that array list. So we've seen how to pretty much implement it, but let's actually get into the finer details. The two methods set and get give ArrayList approximately the same functionality that square brackets will give to arrays. And as I've already mentioned, that's like your accessor and mutator methods here. However, you need to be aware of one important point. The method invocation list.set and the index hi mom is not always equivalent to a of index equals hi mom. Right, so just be careful with that. If we want to add to an array list, the method set can replace any existing element, but you cannot use set to put an element just at any index as you could with an array. All right, it's not quite some of that flexibility. The method set is used to change the value of elements, not to set them for the first time. So you cannot initialize an array list with set. To set an element for the first time, you actually have to use the method add. Add is what actually will initialize the elements with it. Set simply just changes them. So there is a slight drawback in that. Like a lot of times in classes, like, oh, we can just use set method and it'll change the value. Well, with ArrayList, you can't use set to change it, or excuse me, to add an initial value into there. So if we, let's say, had an array before of, let's say, 5 slots for the array list, and we say, hey, we want to add in a sixth one, so we increase the array size. Well, we can't just set the sixth element. We have to add the sixth element. The basic form of the method add pretty much adds elements at index position 0, position 1, 2, so forth within that order. This means that ArrayList must always be filled within that order. But your code then can actually go back and change the individual element just as it can with an array. We just have to use set instead of add. So for example, suppose a list is an array list with base type string, which has not yet had any elements added to it. Pretty much that is, the list is empty. So the following statements would add the strings 1, 2, and 3 to positions 0, 1, and 2. List.add 1, list.add 2, list.add 3. The method name add is overloaded, you'll notice. There's also a 2-argument method named add that allows you to add an element at any currently used index position or the first unused position. So when inserting an array list with this version of add, elements at the specified index and higher, if any, are moved up one position to make room for the new element. So let's just say that you wanted to put a list.add 0 in there. So we want to put it at the 0 index. So it's going to add the string 0, position 0, and it's going to move the elements originally at position 0, 1, 2, and so forth, up 1 positions, 2 positions, 1, 2, 3, and so forth. So this allows you to insert an element right into your array list. Now, suppose the list starts out empty and your code executes our 4 add invocations which we repeat below. List to add 1, list to add 2, list to add 3, list to add 0, 0. After these 4 invocations, the list to add, the list would contain the strings 0, 1, 2, 3 in positions 0, 1, 2, and 3, respectively. Note that the 2-argument version of add cannot add an element at any position. It doesn't quite have that ability. It can only insert an element at some already used position or at the first unused position. The elements in an array list always occupy continuous sets of positions starting at 0. That is, they always start at positions 0, 1, 2, and so forth up to whatever the last position is. This is just like any partially filled array. See, as I mentioned before. But unlike a partially filled array, you do not need to do anything to keep track of how many elements are in the list. So that is one of the big advantages of using ArrayList over a partially filled array, is that you don't have to do this manually tracking. Now, the method size automatically will take care of this for any array list. So you can find how many indices already have elements by using the method size. If list is an array list, list.size simply just returns the size of the array list, which is the number of elements stored in it. The indices of these elements will go from 0 to 1 less than list.size. So we just say for in index equals 0, index is less than list.size, index plus plus, this is on the print line, list.getIndex. All right, here's a quick tip for you, summary of adding to an array list. So to place an element in an array list position at an array list index for the first time, you usually use the method add. The simplest method add has a single parameter for the element to be added and adds elements at positions 0, 1, 2, and so forth. You can then add an element at an already occupied list position by using the 2-parameter version of add, which, of course, remember, will insert it into the array list. When inserting into an array list with a version of add, elements at the specified index and higher are moved up 1 position to make room for the new element. For example, suppose list is an array list object with base type string that has 3 elements already on its list. And then we consider the following invocation, list.add 1, or more. Before there were elements at positions 0, 1, and 2. When this invocation of add is executed, the element or more is inserted at index 1, and the elements of index positions 1 and 2 are then moved to positions 2 and 3. You can also use the 2-argument version of add to add an element at the first unused position. If list has elements at index positions 0, 1, 2, and 3, then the following, of course, is legal. List.add 4, mutual or more. Your code can then go back and change any individual element using set. However, set can reset only the element at an index that already has an element. Right? It can't do it if it's not initialized. The method size can then be used to determine how many elements are stored within an array list. And that's going to wrap up that long list of notes, folks. It's a lot of good introduction here, but let's just close out with a quick demo here, just so you can see the array list here. So here I have, I'm going to set the size of the array list using n. So I'm going to say array list integer, array li. So I'm just saying that it's a array list of, and then new array list integer n. Of course, I could just put 5 here as well, but I'm just using the variable. All right, and here I'm going to append a new element to each one of the list. Notice I'm just going to fill it with 1, 2, 3, 4, etc., etc. Then I'm going to print out the elements. I'm going to remove the element index 3. So this is how you remove them. We didn't really talk about the notes, but this is how you can remove an element. Then I'm going to reprint the array after I deleted it. And then, of course, here is printing out the elements one by one. So if I execute my code, you can see the original list is 1, 2, 3, 4, 5 because I filled it with 5 elements. I removed the third element, so now it's 1, 2, 3, 5. So the list actually shrunk in size. So when you remove, it actually shrinks back down. And of course, if I do the last one, which is print the elements one by one, which is instead of printing out the whole array list, which gives you this, it will actually print out the individual values. So here I get 1, 2, 3, 5. And with that being said, folks, that's going to wrap up our first lesson for Programming 3. And I know it's a lot to kind of take in with something new, but with that being said, I will see you next time.